Hey, statistics students, we are starting a new unit about linear regression, and we're going to get going with some scatterplot basics today. So we have a track and field day for us. The table below shows the data for 6 students in a statistics class. The students ran a 40-yard dash and then did a long jump with running start. Is there a relationship between sprint times and long jump times? Okay. The first thing that we want to go over is just our basics on how to make a scatterplot. Well, in statistics, we have 2 definitions that you need to know. And one of them is an explanatory variable, and one of them is a response variable, okay? So I want us to get that down right now. An explanatory variable is a variable that we think explains or causes changes in the response variable, okay? The response variable is a variable that measures an outcome or a result of a study. Now, when we're plotting a scatterplot, we have an x-axis and we have a y-axis, right? And we need to put the explanatory variable on the x-axis when we're labeling it, and the response variable on the y-axis. Now, sometimes it isn't clear which one is the explanatory and which one is the response, and then it doesn't matter. Oftentimes it is clear, and today hopefully we have picked one that is clear, okay? So pause the video right now and write down these 2 definitions, explanatory variable and response variable. Okay, now we have to ask ourselves, what is the question, or what is the explanatory variable in this case? Does a sprint time, how fast we run, right? Does that cause changes in a long jump distance time, or influence, or cause us to jump faster? Cause, we're going to say it like that. Or does how far we jump influence or cause changes in our sprint time? Hopefully you are thinking that the sprint time explains the changes in our long jump time. The faster we run gives us more momentum to jump off and hopefully go further into the long jump pit, okay? So our sprint time is our explanatory variable that influences or causes us, the faster we run, will influence to jump that longer. The slower we run, right, will influence our jump where we're probably not going to jump as far. Okay, so with that being said, let's draw our x-axis and our y-axis. So I have my x-axis, my sprint time explanatory variable, and my y-axis, my long jump distance. Now, next, you'll notice that I have 5 through 10 here on the x-axis. I did that by looking at my minimum and looking at my maximum. So my minimum is 5.05 and my maximum is 9.49. So I thought it's appropriate I can go by ones here. My long jump minimum is 48, excuse me. My long jump maximum is 184. So I decided to go by 25s, and you'll notice I only have the 50s there just to make it look clean, but I did go by 25s there. Okay, now to make a scatter plot, what we want to do is this right here is an ordered pair, right? So I have 5.41 and 171. That is my X, that is my Y. So 5.41 would be approximately here, we'll say, and 171 would be approximately right about here, and we're going to make a point. Okay, we'll do it again with 5.05. I'm going to move my point over a little bit. Okay, there, just a little bit better. 5.05 and 184. So 5.05 and 184 is approximately right here. Again, it's always approximate when we're doing it by hand. I'm going to pause the video right now just so I'm not wasting your time. You pause it as well and go ahead and plot these other ordered pairs in your notes, okay? Okay, so hopefully you have a graph that looks something like this. Again, each point was an ordered pair. We go to the X, we go to the Y, we put a point, okay? What should we have learned so far? How to make a scatter plot, what is an explanatory variable, and what is a response? And sometimes it's not clear. If you have questions, just let me know. This one's hopefully pretty clear. Now, the next thing we need to learn is how to describe that scatter plot. Just like when we would describe a histogram or when we describe a box plot, we now also want to describe the scatter plot, okay? Okay, so anytime you're asked to describe the scatter plot, we have something or another acronym. Just like we had SOCS or SUCS before with Unit 1, now we have SUDS, okay? And what does that stand for? So S stands for the shape of the scatter plot, or some people call it the form of the scatter plot, okay? And what you want to look at is you want to say, is that scatter plot, if I drew a line through it, a line of best fit, like you learned in your algebra classes, if I would draw a line of best fit, would it be linear? Would it be straight? Or would it be more curved, okay? So we want to look up here and we want to say, hey, what does this look like? And this looks, I would say, if I would draw a line of best fit, now a line of best fit would be where I would have approximately half the points above, half the points below. I think this would maybe be my line of best fit, approximately, okay? I think that's pretty linear. I might want to, because of this point, move it up just a little bit, and then maybe more like that, adjust it a bit. But again, okay, this is looking like linear and not curved. Now, the AP world is not going to try to trick you, so it will be one or the other, okay? Shape. The next thing is, are there any unexpected points? Anything that seems really out there that, I call it the Shaquille O'Neal factor. If we were measuring our shoe length, right, and our height, typically as your shoe size goes up, people's height also increases. And then Shaquille O'Neal walks into the room and he's like way up here, right? He's got really big feet and he's really tall. Okay, so is there like a Shaquille O'Neal factor, or is there something really unusual? It doesn't seem to fit the pattern, okay? So let's look up here. I would say this could possibly be unusual. This person here jumped at, I believe it was 8.09 seconds. Okay, that's not particularly fast by any means, but jump decently far, okay, decently far. So again, now with our scale here, it could be skewed off a little bit, but it's just a sketch right now, so we're okay for now, okay? So again, anything unusual, anything particularly doesn't seem to fit that pattern, we can maybe say that's a potential one, okay? The next one, it would be the direction. Is the graph going in a positive direction or a negative direction? Meaning when we read the graph left to right, is it going down or up? We actually call it a positive association. Association means relationship, or a negative association. And you can see here that we have a negative association with the graph. And then finally is the strength, okay? I call this the oval test. Now, let me be clear. The oval test is not an okay way to justify when you're asked to describe a distribution. The oval test is just a way for me to teach you to think about it. Do we have a strong association or do we have a weak association? Now, how can I tell? That strength is how close does it follow to the form, to the shape? So if we're saying it's a line, is it close to this line or not? So what I like to think is, envision an oval. If we would draw an oval around these points, okay, the thinner that oval gets, right, the closer to a perfect straight line it is. The thicker that oval gets, the closer to not a line it is, and the relationship would be very weak then, because your strength is how close it follows to the form. So again, an oval that is thin, right? That's going to be very close to that line, meaning you have a very strong relationship. As it gets weaker, okay, it's going to get closer to a circle. Okay, so how can we describe the form? The strength. We can use words like very strong, strong, moderate, weak, okay? So what would we say here? I would accept on this one anywhere from strong to moderate, okay? A moderate or a moderately strong relationship. Some people, this is unsettling. Don't worry, we're gonna have numbers that are gonna help us decide how strong this is later. But for now, we just need to feel comfortable with, hey, can I look at the shape? Is it linear or not? Does there seem to be anything unexpected from that pattern? What's the direction? And how strong, from my opinion, is it going to be? Okay. So there's going to be some wiggle room because I know we can't say, oh, it's for sure moderate or it's for sure not. We're going to figure that out later. Now, with everything, we need to do this in context, okay, of the situation we're talking about. So we're going to do that right now. Okay, so as I was saying, we need to use this suds to describe the relationship, okay? We need to do that whenever you're asked to describe the relationship, okay, or what type of relationship it is. I am looking for those 4 things in context. So what would I say look for on a test? The relationship between sprint time and jump distance is linear. I like the word appears, to be honest. I should have said that. And I went ahead and said, this isn't too unexpected. I would say based off this line of best fit that I just sketched with half the points above and half the points below, if this is unexpected, then maybe we would have to say this one is as well, just looking at the distance to the line. So maybe you're asking, well, what would be unexpected? Something like here or way over here, you know, something like that Shaquille O'Neal factor. And we're going to practice that so you're going to see what really does look unexpected or an outlier, as we would say, okay? So I said with no unexpected points. So I have my S and my U there in context. It has a negative association, right? Because it's going down. And I went ahead and I said that this was moderately strong. We have a couple that are right next to the points, right? And then this one's not, I'm sorry, we have a couple points right next to the line. And then, so if we would take away these points right here, this point here and this point here, that oval will be really thin. So we would say strong. But because I have this point right here and this point right there, that, you know, makes it a little wider. And that's why I'm deciding to call it moderately strong. So there we go, guys. Pause it and write this down. The relationship between sprint time and jump distance appears to be linear with no unexpected points. It has a negative association and is moderately strong. S, U, D, and S all in context. Perfect. Now, if you're feeling a little uncomfortable, part 2 is coming, and that's where we're going to talk about something called the correlation coefficient. And that's going to help us decide a little bit better about that strength of that relationship. I'll give you a little more concrete. Remember, I did not discuss the oval test here. Okay, remember that. All right, we'll see you guys for part 2.